Hi, this is Sung, the Principal and Director of Sky Academy, and we are basically going through, at the moment, geometrical applications of calculus, and in particular we are looking at the geometrical applications of differentiation. Now in the last episode what we looked at was how differentiation, or the first derivative of a function, represents the gradient of the tangent to the function at the point of contact to the curve. Okay? And we looked at the different types of gradients that you can have. You can either have a positive gradient or a negative gradient, or the other type of gradient that you can have is a zero gradient, where the curve actually flattens out. Okay, and so the tangent will look totally flat. It's a zero gradient. Those sort of curves are called stationary points, and that's particularly what we're going to be looking at today, okay, in this episode. Stationary points and the different types that they have. So let me just go through a quick recap of what stationary points actually are. Stationary points occur when the first derivative of a function equals to zero. It's when the curve has a zero gradient, okay? And there's three types that I want to look at today, okay? And they're on the board right behind me. They are maximums, minimums, and points of inflection, okay? Maximums, the plural is actually maxima, minima, and points of inflection, okay? So let's have a look at a maximum. It's basically where the point hits a maximum value and then turns on itself, right? And so the gradient at the very top actually goes from being, in this particular case, positive, 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 positive. The gradient becomes positive, and then it equals zero and changes signs and starts becoming negative, 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 right? So what you can see is that f dash of x is positive here, positive there, it continues to be positive, and then it's zero at this point, right? And this point is a special type of stationary point called a turning point, and it's called a turning point because the curve turns in on itself and goes the other direction, and goes from being a positive gradient through to being a negative gradient again. Yeah? And so you can test whether a function is a maximum or a minimum by testing the first derivative. We will know that at x, yep, the first derivative will be zero because it is a stationary point, but before it, it will be positive, and after it will be negative. Does that make sense? For the value less than x, it will be positive, and for the value greater than x, it will be negative. Okay? The next type is a minimum, and the minimum is the exact opposite of a maximum. So basically what happens is that you start off with a negative gradient that is negative all the way to the point where it turns on itself, and that point is called a turning point, remember? And then it starts going in a positive direction. And so at x, the minimum will be zero. So at x, the first derivative will be zero. And before x, it will be negative. And after x, it would be positive. The exact opposite to a maximum. Okay? The last type of stationary point is called a horizontal point of inflection. Alright? Let's see what happens at a horizontal point of inflection. And there's two types. One that I've done in blue and one that I've done in red. But they're really all just one type of horizontal point of inflection that are two sides of the same coin, basically. Okay? So in this situation, let me follow the blue curve for the time being. Okay? You have a positive gradient that flattens out to zero and then continues on its positive way. Do you see that? Now, does the curve turn in on itself? No, it doesn't turn in on itself, so it is not a turning point. Okay? Of the three types of stationary points, only maximum and minimum points are turning points. The third type is a horizontal point of inflection. It is not a turning point. And this is a point where often a lot of students get stuck. It's what we call a horizontal point of inflection. The opposite is true for the red curve. In this particular case, it's exactly the same, but the gradient is negative all the way to this 0 point, and then it goes on its negative merry way. Does that make sense? Okay, so what will the graphs, so what would that look like algebraically? So at x and at greater than x and less than x, what's going on? Well, in the red case, you're going from negative and then going to 0 and then negative again. And for the blue case, you're going positive, 0, positive. Where there is no sign change, so where there is no change from positive to negative, where it goes from positive, 0, positive, that is what we call a horizontal point of inflection. It is not a turning point. It's not a turning point. Okay? So hopefully that'll give you some ideas of the natures of different types of stationary points. And the questions that you're going to get on this particular concept are questions like find the stationary points of a particular curve and then determine their natures. And what that means is determine whether they're maximum, minimums, or horizontal points of inflection. Thank you for watching.